Calculation of array voltages. We define the array as a combination of series and parallel connected modules. And the array voltage, it is the multiplication of the, let's say, series connected modules, the number of series connected modules, by the open circuit voltage of one module. This is how to get the array voltage. We know that there is a relation between the temperature and the voltages. As the temperature increases, the array voltage decreases, and as it decreases, as the temperature decreases, the array voltage increase. So we need to consider this in our design. It's a vital step actually to design the array voltage or the string voltage. So we use this equation to correct for the temperature at, let's say, to correct the open circuit temperature at a lowest expected temperature, and we use this equation to correct at a maximum expected temperature, where alpha is the temperature coefficient factor, and delta T, it is the temperature difference between the cell temperature minus 25 degrees, which represent the STC temperature. So there is one thing, that the cell temperature is different than the ambient temperature. So for example, when we are going to correct at a high temperature, we need to use this equation to get the cell temperature. And this equation actually represents that the cell temperature equal to the ambient temperature plus G, which is the irradiance at which we are going to correct, and 800 and knocked, which is the knocked temperature, which is available in datasheet for each module, minus 20 over 800. Knocked temperature, it is in the range of 40s, and it will vary from one manufacturer to the other. So this is how to get the cell temperature, which is different, as we said, from the ambient temperature. So here we have an example, and we are going to correct for the voltages at lowest temperature. From the datasheet of the module, we get the open circuit voltage and the temperature coefficient, which is minus 0.34% per degree Celsius. And some of the data sheet, the ambient or the temperature coefficient comes in this form, minus 175.8 millivolts per degree Celsius. We want it to be in percentage per degree Celsius so that we can use it in the previous equation. So to convert it to this form, we just take this value, divide it over the open circuit voltage, we get it in percentage. So we need also to know the maximum inverter or inverter voltage, and in this case it was 1000 volts, and also the lowest temperature for that site we anticipate that it is minus 10 degrees. So we use the equation, as we said, the corrected or maximum open circuit voltage is equal to the STC open circuit multiplied by 1 plus the temperature coefficient multiplied by the temperature difference. And after substituting all of these values, we get that the voltage 57.85 volts, which is greater than the STC open circuit voltage, which is an expected value, since we said that the let's say the lowest temperature will increase the voltage. To know the maximum let's say number of series connected modules in a string, we need to divide the maximum inverter voltage over the module open circuit or the corrected open circuit voltage, which is in this case 57.85 volts, and we get 17.28. To be in the safe side, we need to round it down so that we don't exceed the 1000 volts. So in this case, we will select it as 17 modules as the maximum number of series module that can be connected in series. Now we come to correcting the voltages at high temperature. From the datasheet, we get the maximum power voltage, which is 43.1, and the temperature coefficient minus 0.37 percentage per 25 per degree Celsius. And also from the inverter datasheet we get the minimum voltage for the inverter is 150 volts. And here we know that maybe in some places that the ambient temperature can goes up to 60 degrees Celsius. So we will put it in the previous equation to get the cell temperature. And in this case, the cell temperature is 85. And we see that there is a difference between the cell temperature and the ambient temperature. So using the previous equation, we put all of these known values. We get that the maximum power voltage or the minimum voltage is 33.57, and this due to the let's say the high value of the temperature. To know the minimum number of modules that can be connected in series in each string, we just take the 100 volt which is the minimum inverter voltage over the module minimum voltage, we get 4.47. And to be in safe side, we need to round it up so that we guarantee that we are above the minimum accepted voltage. So we come up with 5 modules. So as a summary, our series connected modules in a string shall not, exceed these limits from 5 to 17. We could select any number between 5 to 17.